everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable questions. So let's get going. Problem solve x cube d cube plus 2x square d square plus xd minus 1 into y equals to cos of log x. So here we are given a differential equation with variable questions, right? Now we are going to reduce this to a differential equation with constant questions by making some substitution, and also we are given a Cauchy's equation. Solution. Given differential equation, x cube d cube plus 2x square d square plus xd minus 1 into y equal to cos of log x, and also this is a Cauchy's equation. Now we need to make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to dy dz. Here theta is a differential operator with independent variable z. Then xd equals to theta, and x square d square equals to theta of theta minus 1. We can write it as theta square minus theta, right? And x cube d cube equals to theta of theta minus 1 into theta minus 2, which is equals to theta into theta minus 1 is theta square minus theta of theta minus 2, right? This equals to theta square into theta is theta cube minus 2 theta square minus theta into theta is minus theta square minus into minus plus theta into 2 theta. This is equals to theta cube minus 2 theta square minus theta square is minus 3 theta square plus 2 theta. Now substitute x cube d cube x square d square xd and log x in the above equation. We'll get replace x square d cube by theta of theta minus 1 into theta minus 2 plus 2 into x square d square can be replaced by theta of theta minus 1 plus replace xd by theta minus 1 into y equals to cos of replace log x by z, right? Then theta of theta minus 1 into theta minus 2 is theta cube minus 3 theta square plus 2 theta plus 2 into theta of theta minus 1 is theta square minus theta plus theta minus 1 into y equals to cos z. Then theta cube minus 3 theta square plus 2 theta plus 2 theta square minus 2 theta plus theta minus 1 into y equals to cos z. Then here plus 2 theta minus 2 theta gets cancelled, and we'll get theta square minus 3 theta square plus 2 theta square is minus theta square plus theta minus 1 into y equal to cos z. So we have reduced the given differential equation with variable equations to a differential equation with constant questions, and also this is in operator form f of theta into y equals to some function of z, which is in operator form f of theta into y equals to q of z, where f of theta equals to, this is theta cube, right? Theta cube minus theta square plus theta minus 1. Now we need to find the general solution to the given equation, which is given by y equal to yc plus yp. Okay, we'll find yc using the auxiliary equation, and later we'll go for yp. The auxiliary equation is f of m equal to 0 where f of m equal to, we have f of theta, theta square minus theta cube, theta cube minus theta square plus theta minus 1. Let's replace differential operator by m, so that we'll get f of m equals to m cube minus m square plus m minus 1. Then our auxiliary equation becomes m cube minus m square plus m minus 1 equals to 0. Now we are going to find roots using synthetic division method. Now place the equations. Minus 1, 1, quotient of m square minus 1, and the quotient of m cube is 1. Now let's see which m is going to satisfy the polynomial m cube minus m square plus m minus 1. Okay, let's try for m equals to 1. We'll get 1 minus 1 plus 1 minus 1. 2 minus 2 is 0, right? So m equals to 1 satisfies the polynomial m cube minus m square plus m minus 1, right? Put 0 here. 1 plus 0, 1. 1 into 1, 1. Minus 1 plus 1 is 0. 1 into 0, 0. 1 plus 0, 1. 1 into 1, 1. Minus 1 plus 1 is 0. Again, this gives one more polynomial m square plus 1, right? So from m equals to 1, we'll get m minus 1 equals to 0, right? So we can write the polynomial as product of m minus 1 into m square plus 1. If you want, you can check it. See, m square plus 1 into m minus 1 gives m square into m is m cube, m square into minus 1 minus m square, plus 1 into m is m, plus 1 into minus 1 is minus 1. We'll get the polynomial, right? So we can write auxiliary equation as product of m minus 1 into product of m minus 1 and m square plus 1 equal to 0, right? Now equate each factor to 0. See, from the first we'll get m minus 1 one factor, and from this we'll get another factor, right? Now equate each factor to 0 in order to find roots. From m minus 1 equals to 0, we'll get m equals to 1. From m square plus 1 equals to 0, we'll get m square equals to minus 1. Then m equals to plus or minus square root of minus 1. Since we know that square root of minus 1 is I, now replace square root of minus 1 with I. So the roots are m equals to 1 and plus or minus I. Then m equal to 1 plus or minus I are the roots of our auxiliary equation. One real root and a pair of complex conjugate root, right? Here one is a real root and plus or minus I is a pair of complex conjugate root. Okay, fine. We know that when m1 is a root, then yc will be c1 e power m1 into z, right? For a real root. If we have, okay, if a plus ib is a complex number, its conjugate is a minus ib. If a minus ib is a complex number, then a plus ib is conjugate, right? So we call m equals to plus or minus, a plus or minus ib as a pair of complex conjugate. If we have a plus or minus ib, complex conjugate roots, then yc looks like e power a into z into, take two constants. Here we have used c1 already, right? So let's take c2 and c3 as our constants. We'll get c2 cos bz plus c3 sin bz, right? In case of a is 0, we'll get e power 0 into z, which is e power 0, right? Into c2 cos bz plus c3 sin bz. We know that since e power 0 is 1, so this becomes c2 cos bz, or 1 into c2 cos bz plus c3 sin bz, right? Which is equals to c2 cos bz plus c2 sin bz. Now coming to our complementary function. yc equals to, for real root, one real root, we'll get c1 e power that real root into z plus, for plus or minus I. In case of a is 0 and for b equals to 1, we'll get c2 cos 1 into z plus c3 sin 1 into z, right? yc becomes c1 e power z plus c2 cos z plus c3 sin z. Now we are having yc in terms of z and we need to write in terms of x. So we'll replace e power z by x and z by log x. Then yc becomes c1x plus c2 cos of log x plus c3 sin of log x. So this is our required yc. Now we need to find yp. Particular integral. We'll find yp using 1 by f of theta into q of z. We have f of theta and q of z, right? Where f of theta is theta cube minus theta square plus theta minus 1 and q of z is cos z. So this is of 1 by f of theta into cos az form, right? Now compare cos z with cos az. And for a equals to 1, we'll find theta square, which is given by minus of a square, which is equals to minus of 1 square, which is equals to minus 1. Okay, we have denominator d cube minus theta, theta cube minus theta square plus theta minus 1. Now we have to see, after replacing minus 1, the denominator must be non-zero. So we'll check what happens if we replace theta square by minus 1. For that purpose, we'll write theta cube as theta square into theta, right? And remaining will be as it is. This is into and this is minus. Now, replace theta square by minus 1, we'll get minus 1 into theta minus, replace theta square by minus 1 plus theta minus 1. This equals to minus theta plus 1 plus theta minus 1. Here minus theta plus theta gets cancelled, plus 1 minus 1 gets cancelled, and this is equals to 0. If we replace theta square by minus 1 in the denominator, we'll get 1 by 0 into cos z, right? Since 1 by 0 is undefined, so total term becomes undefined. So here we cannot replace theta square by minus 1 in the denominator because we'll get some undefined term, right? This equals to, just write 1z into 1 by, find derivative of f of theta. If f of theta is theta cube minus theta square plus theta minus 1, then f dash of theta will be 3 theta square minus 2 theta plus 1, right? Just write it down. theta square minus 2 theta plus 1 into cos z. Now let's see what happens if we replace theta square by minus 1 in the denominator. We'll get theta of minus 1 minus 2 theta plus 1 equals to 3 into minus 1 is minus 3 minus 2 theta plus 1, which is equals to minus 3 plus 1 is minus 2 minus 2 theta, which is a non-zero term, right? So we can replace here. Just replace theta square by minus 1. Then we'll get z into 1 by 3 into minus 1 minus 2 theta plus 1 into cos z. This is equals to z into 1 by minus 3 minus 2 theta plus 1 into cos z. Now this becomes z into 1 by minus 3 plus 1 is minus 2 minus 2 theta into cos z. Now take minus 2 common from the denominator. We'll get z into 1 by minus 2 times 1 plus theta into cos z. See, minus 2 into 1 is minus 2. Minus into plus minus 2 into theta, 2 theta, right? Now, is equals to z into, now split the fraction as 1 by minus 2 into 1 by 1 plus theta into cos z, right? This is equals to z into, we can write 1 by minus 2 as minus 1 by 2. Now, see in the denominator we are having 1 plus theta in the second fraction. So, if we replace this plus by minus, we'll get 1 minus theta. Now, multiply and divide 1 minus theta to the second fraction. Okay, then we'll get z into minus 1 by 2 is minus z by 2 into 1 into 1 minus theta is 1 minus theta by 1 plus theta into 1 minus theta into cos z. Then yp becomes minus z by 2 into 1 minus theta by, so the denominator is of a plus b into a minus b form, we can write it as a square minus b square, a square minus b square, right, into cos z. This is equals to minus z by 2 into 1 minus theta by 1 minus theta square into cos z. Again, theta square appears in the denominator, so what we have to do, we have to replace theta square by minus 1, right? We have theta square equals to minus 1, and now let's see what happens if we replace theta square by minus 1 in the denominator. Always remember that the denominator must be non-zero. So we'll get 1 minus of minus 1, which is 1 plus 1 equals to 2, a non-zero number, right? So we'll get minus z by 2 into 1 minus theta by, just replace theta square by minus 1. We'll get 1 minus of minus 1 into cos z, which is equals to minus z by 2 into 1 minus theta by 1 minus into minus plus 1 into cos z. This is equals to minus z by 2 into 1 minus theta by 2 into cos z. This becomes minus z by 2 into, now split the fraction as 1 by 2 into 1 minus theta into cos z. This is equals to minus z by 2 into 1 by 2 is z by 2 2s are 4 into 1 into cos z is cos z minus theta of cos z. We know that theta is a differential operator, right? Just replace theta by d by dz. Now we need to find derivative of cos z with respect to z. This is equals to minus z by 4 into cos z minus of derivative of cos z with respect to z is minus sin z. Right? This is equals to minus z by 4 into cos z minus into minus plus sin z. Right? Now we are having yp in terms of z, but we need to but we need in terms of x. So what we'll do, we'll just replace z by log x. Then we'll get minus log x by 4 into cos of log x plus sine of log x. Or we can write it as minus 1 by 4 into log x of cos of log x plus sine of log x, or minus 1 by 4 into log x into cos of log x minus into plus minus 1 by 4 log x into sine of log x. This is our required value. We are having yc and yp. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equal to yc, we have c1x plus c2 cos of log x plus c3 sine of log x plus yp minus 1 by 4 into log x cos of log x minus 1 by 4 into log x sine of log x. This completes the problem. So we have seen a problem from higher order linear differential equations with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.